Looking at the last three examples that we're going to do for chapter 23, we're going to do number 2, 3, and 5 from the handout I gave you guys in class. If you lost it, it is posted to iTunes U. So number 2 says that a company has set a goal for developing a battery that lasts over 5 hours, which is 300 minutes in continuous use. In the first test of 12 of these batteries, they measured the following lifespans in minutes. So that list is given right there. We want to know, is there evidence that the company has met its goal? And we're going to use a 90% confidence interval to do this. The first thing that we have to do here is check our assumptions and conditions. So the first one is random. There's no reason to think the batteries are not random and independent. Then we have the 10% condition, and the company makes enough batteries that 12 is going to be less than 10%. So 12 is less than 10% of all batteries made. Then we have our nearly normal condition, where we actually have to make a histogram and check that it is actually unimodal and symmetric. So in this case, if we do that, we end up with a histogram that looks something like this, which is approximately unimodal and symmetric. I ran out of room here, but you would want to write next to the histogram that it is, in fact, unimodal and symmetric, or roughly. Good enough for us, at least. After we've checked our assumptions and conditions, we can move on to actually doing the mechanics of the problem. So we're going to do a one sample t interval. So that confidence interval is equal to the sample mean plus or minus our margin of error, where the margin of error is calculated as a critical value, in this case with 11 degrees of freedom, times the standard error, which in this case would be s over the square root of n. So this ends up giving us a confidence interval of 306.25 plus or minus 1.796 is our critical value, and I got that by looking it up in the back of the book in the t-table, times the standard deviation of the sample was 29.31 divided by the square root of n, so divided by the square root of 12, and this gives us an interval of 291.05 to 321.45. Once again, the 11 means that we have 11 degrees of freedom, so that's one less than our sample size. I found that from the back of the book in the table, and I got the mean and then the sample standard deviation from our list of data. So really what I did is I typed in my data into my stat editor, and then I did a t-interval. And it actually, when you do the t-interval on your calculator, it gives you both the mean and the standard deviation, as well as the actual interval. So you don't really have to do any math at all, because the important part is what comes next, and that is the interpretation. So for this interval, which was, again, 291.05 to 321.45, so based on this sample, we are 90% confident that the average battery life lasts from 291.05 minutes to 321.45 minutes. Because our interval dips below their goal of 300 minutes, we can't actually say that the company has met their goal. Now they might have, but we don't know that because, again, the interval goes below, so it could still be under 300. Moving on to number 3, radar was set up in a neighborhood to let drivers know how fast they are going in hopes to reduce speeding. One resident stood where he could see the radar and recorded the speed of every car for a 15-minute period. Apparently, he had nothing better to do. After observing 23 cars, the average speed was 31 miles per hour with a standard deviation of 4.25. we want to know, does the average speed exceed the posted speed limit of 30 miles per hour? So we're going to do a hypothesis test in this case. When we do a hypothesis test, the first things we need are our null and alternative hypothesis. So my null hypothesis here is that everything's the same, all hunky-dory, nothing different. So that would mean that the mean is 30 miles an hour. The alternative, we're trying to determine if the average speed exceeds that. Exceeding means that you're going over that, so the mean would be greater than 30. Then we have to check our assumptions and conditions. So I'm not going to write them, I'm just going to explain them, but I will list them. So again, we have random. So there's no reason to believe that the order that the cars are going through that portion of the neighborhood is not random, and no reason to believe that one car driving is not independent from the other car. Then we have 10%. So this one is a little trickier because we would have to know that there are at least 230 cars driving through that neighborhood. But again, because there's no reason to believe that how fast one car is going to affect the next car that's driving past, there's no reason to believe that they're not actually independent. And then we have the nearly normal. Now in this case, we don't have the data, so we cannot actually make a histogram here. So when we're checking the nearly normal, you're going to actually have to think about the situation. Does the situation appear that there would be some people going slow, the majority being right around the speed limit, and then some people going faster than the speed limit? And it seems like that would be pretty standard, that you're going to have less people going below the speed limit, the majority of people going right around the speed limit, and then a few people speeding. And that seems like that would be reasonable, that it would follow the bell-shaped curve. So the nearly normal would be met, but you would actually have to write each one of these out. Once we check our assumptions and conditions, we then do the mechanics. So again, you're going to type this information on your calculator. So we don't need the 15-minute period. That's just excess data. But when you go to your calculator and you do a t-test, n is 23, your mean is 31, your standard deviation is 4.25, and the null hypothesis is 30. And then you would type everything in just with that information after you click statistics, not data. So in this case, the work to show for the mechanics is going to be t sub 22, because we have 22 degrees of freedom, equals our observed mean of 31 minus our null hypothesis of 30 divided by our standard error, which is the standard deviation of our sample divided by the square root of n. And in this case, we get a t-score of 1.13. That t-score gives us a p-value of 0.136. And that would be from this diagram right here. Once we have our p-value, we can then write our conclusion. In this case, with a high p-value, we would fail to reject our null hypothesis. So then, with a high p-value of 13.6%, we fail to reject the null hypothesis. There is not enough evidence to suggest the average speed exceeds the posted limit. Now, it's important that if you fail to reject the null hypothesis, that means that you're retaining it. So we can't prove the alternative. So since we failed to reject the null, we would cross out the alternative. So our context is finding in favor of that. So we need to make sure that we say that there's not enough evidence to suggest the speeding. Moving on to number 5, it's the same situation that we had in number 2. A company has set a goal for developing battery life that lasts over 5 hours or 300 minutes in continuous use. So again, they tested 12 batteries and they measured the following lifespans, again in minutes, and this data is the same as number 2. We want to know, is there evidence that the company has met its goal? And now we want to use a hypothesis test. So we kind of already showed in number 2 that the company did not meet their goal, but we're going to double check that by getting a p-value, which is a little stronger than just using a confidence interval. So when we're doing a hypothesis test, the first thing we do is state our null and alternative hypotheses. So our null hypothesis is that the mean is equal to 300. Our alternative hypothesis, we're trying to show that the company met their goal, which means that the battery lasts over 300 hours, so mu would be greater than 300. Now, we already checked the assumptions and conditions in number 2, so I'm going to say that we don't need to do that again. So we're going to move on and go ahead and calculate our t-score. And again, this is the same thing that we do to calculate the z-score. So the t-score is calculated as t sub 11, because there are 11 degrees of freedom, one less than the sample size of 12, is equal to the sample mean, which is 306.25, minus your null hypothesis of 300, divided by the standard error, which is the standard deviation of the sample, 29.31, divided by the square root of n, which is 12. This gives us a t-score of 0.739. Our t-score is under 1, so that kind of indicates that we're probably going to have a pretty high p-value, but we still have to calculate the p-value just to make sure. And our p-value in this situation ends up being 0.238, and again, it's because we would have something that looked like this. We would be looking for that area, which would be about 23.8%. Because our p-value is high, we end up failing to reject our null hypothesis. Now, before I write up the conclusion, I want to go over how I was able to come up with the t-score as well as the p-value. Again, once you type the data into your calculator, you would do a t-test. You can, because we have the data, we would select data to run the test from. When you run the test will give you what the mean and sample standard deviation are, and then you just have to write it out as you have seen here, and it will give you what the t-score is, and it will give you what the p-value is. And then again, the important part is our conclusion. So that's where we really focus. So our conclusion is with a high p-value of 23.8%. We failed to reject the null hypothesis. This means that we are not finding in favor of our alternative. We are indeed finding in favor of our null. We're retaining our null hypothesis. So there is not enough evidence to suggest that the company has met their goal of over 5 hours. Okay, so those are the last 3 examples that we had to do. So that is it, and if you're watching this, I hope you guys have a good night, and I will see you tomorrow morning.